Alright, next video, this is 8.2, alright, so solubility and solubility curves. Once again, we've covered this in class, but if you missed the video or want to go back, I'm going to look over some of the notes. I've put it on here for you. So we're going to look at solubility and solubility curves. Here we go. Alright, like I said, lots of definitions in this chapter. Solubility is a definition you need to know. This is the maximum amount of solute that can dissolve in a given amount of solvent at a certain temperature and pressure. We are not going to worry about pressure for a while. We'll talk about it later in the year. Temperature will come into play here. Let's go back over some terms. The maximum amount of solute. Remember, the solute is what's being dissolved in a given amount of solvent. Right? If you've ever tried to dissolve sugar into water or salt into water, okay, you can have a container and you can put salt in it or sugar in it, whatever, and dissolve and dissolve, dissolve. Alright? Eventually, though, you'll add it and it'll just start building up to the bottom, meaning your container cannot hold, right, or your liquid, in this case water, your solvent, can't hold any more solute. It can't dissolve anymore. Alright? So there's a certain amount of solute we can dissolve, right, into a solvent. I'm talking about the solute being sugar, the solvent being water. There's only a certain amount of sugar you can dissolve into water. Alright? Eventually, if you put too much in there, it just goes to the bottom. It will not dissolve anymore. Alright, this is known as solubility. Alright, there are three more vocab terms you need to know, and they're types of solutions. Let's first talk about this one, a saturated solution. Here's how a saturated solution works. Okay? Here's my solution, or my solvent. We're going to use water again. We'll put salt in it. Alright, you put salt in it. Okay? So you put salt in it. It dissolves. Alright? If you can add a little more salt in it and it still dissolves, you're not there yet. Okay? You're not saturated. A saturated solution is the maximum amount of solute that can dissolve in a given solvent. Alright? At a certain temperature. So how you know you have a saturated solution is you will keep adding your solute, in my example down here, salt and water, until you add some salt and it does not dissolve anymore. And it starts to build up on the bottom here. So you start adding some salt and it starts to build up on the bottom. That's when you know your solution is saturated. You can't dissolve anymore. It just builds up on the bottom. You have a saturated solution. It holds the maximum amount of solute possible. Unsaturated solutions. Let's once again say you have a container of water and salts. Let's just say I add in barely any salt. Boom. I dissolve it all. Okay, an unsaturated solution is mean you have less dissolved solute than particle. How can you test it? Well, if I add some more salt in here and it dissolves, that means that solution was unsaturated, right? Because it could dissolve more. So how you know something's unsaturated is if you add your solute to it and it dissolves, you know that solution was unsaturated. The last one's my favorite. It's a super saturated solution. Alright. A supersaturated solution is a solution that holds more solute than it's supposed to at a given temperature. Alright, how does this work? Well, this works like so. We keep mentioning this word temperature here, right? If you heat up a solution, you can actually dissolve more solute in it than if it's cooler, if it's a solid. Okay, so if I want to dissolve more sugar, alright, into a liquid, if I'm making like the best Kool-Aid ever, what I can actually do is heat up my Kool-Aid. Actually, you can bring it up to a boil. You can actually dissolve more of your Kool-Aid and your sugar in it than you would if it was cold. Alright? But then what you're going to do is you're going to let it cool down. Alright? To make a supersaturated solution, you put more, you go heat it up so you can put more into it to dissolve, then you let it cool down. Well, what happens in a supersaturated solution, if you make it right, is when you let it cool down, it actually, all that stuff that dissolved in it stays dissolved. Right? So it has way more in it than it's supposed to at that temperature. If I had it at 20 degrees, right, and I added some sugar into it, I can only dissolve so much. But if I heat it up, I can add more, and when I cool it down, it stays dissolved. That's a supersaturated solution. It does not happen for all solutes. Alright, there's only some solutes that can do this. But I do have a video to show you a supersaturated solution, okay? And here's the video. Alright, what we have here is a supersaturated solution. Alright, inside of this burette right here is sodium acetate. Okay, it's super saturated, so there's more sodium acetate dissolved in the water than there's supposed to be at this temperature. And what I'm going to do is I'm going to drop it onto this Peachtree dish. Now you're going to see right here without the glare that I've got a little sodium acetate already here. When the sodium acetate solution, supersaturated, hits it, it will come out of solution, meaning the solid that's dissolved in here, okay, will come back and you'll see it again. And it should build up a column here, and you'll see the sodium acetate start to build up. So here we go. We're going to drip it here. Alright, and as it starts to drip, you should see this column starts getting bigger and bigger. So what's happening is this liquid hits the sodium acetate, okay, this solution I should say, hits the sodium acetate, and the sodium acetate falls out of solution, so the solid starts to reform. Right, this is a really quick version of what's happening with stalactites and stalagmites in caves. Okay, that water drips a lot slower, and the buildup is slower, but the minerals that's in a cave, in the water, right, hits the minerals right down there, and they fall out of solution, and they start to form these columns. We're just doing it a little faster. So supersaturated solution, sodium acetate drops down, hits this, falls out of solution really quickly, and there we go. Solid sodium acetate starts to form. Alright, so hopefully you enjoyed that video. This is just another supersaturated solution. This is a picture I took here. This is actually at Yellowstone. This is a hot spring here. And what happens is, at Yellowstone, if you don't know anything about Yellowstone, there's these things called geysers. And what happens is water builds up under the ground under lots of pressure, and it's really hot. And when it comes out of the ground, it starts to cool down. Well, under the ground it dissolves a whole bunch of minerals. When it comes out, those minerals are dissolved in the liquid, right? But it's not, all the solutes not supposed to be dissolved in there. It's a supersaturated solution. So just like the video you just saw of the solids start to build up as the drops started coming down, well, these white spots all that you see in here, and there's a lot of them, this is minerals. These are minerals building up from underground. Because this is water over top, right? This is water over top here. It's probably maybe hard to see. It's a hot spring. So this is water coming out. And all those solute particles, those minerals that dissolve, actually start depositing here. Just like the solid you started seeing build up in the video. Okay, so this is actually a real life example of a supersaturated solution at Yellowstone National Park. Alright, now we get to the fun stuff. This is called a solubility curve. There's some things you need to notice here. Alright, first of all, your x-axis has temperature. Your y-axis is the solubility in grams of your different solutes. There's actually 1, 2, 3, 4, 5 different solutes on here. So this is actually a graph of 5 different things. There's something else here that you need to notice, and that's this is being done in 100 grams of water. Alright, we're going to come back and forth and use this. I'm going to show you how to use this so you can do your worksheet. Alright, so using a solubility curve, points that collectively make up the curve on the solubility curve, points on the curve, represent what type of solution? Right. So we're just going to look at this curve here, calcium chloride. All these points right here, a solubility curve is the maximum amount of solute at given temperatures. You'll notice, all right, that as the temperature goes up, this is how much we can dissolve of calcium chloride. So 60 grams, then 70, then 80, then 90. So as this temperature goes up, we can dissolve more and more calcium chloride. And this line, and all the points on this line, represents a saturated solution. So this is saturated. Alright, points that fall below the curve. Alright, let's say I put 50 grams of calcium chloride in at 10 degrees Celsius. So I only put 50 grams in it, so it falls under the curve. I can dissolve about 63 grams, but I only put in 50. So any points that fall below the curve for calcium chloride, if I'm talking about potassium chloride, it's down here. Okay, this orange line here. If they fall below the curve, this is called an unsaturated solution. Alright, now this next one's tricky. Any points that fall above the solubility curve, alright, if all the solute is completely dissolved, and that's very important, okay? So if it falls above the curve and it's completely dissolved, so if I somehow dissolved 80 grams of calcium chloride, all right, at 10 degrees Celsius, you notice it falls above the curve and it's completely dissolved, this is called a super saturated solution. Now, I keep emphasizing it's got to be completely dissolved. If you remember in the sample I gave earlier for a saturated solution, let's say we just poured in 80 grams of calcium chloride at 10 degrees Celsius. All right? What will happen is this much will dissolve right here, 10 degrees Celsius. About 63 grams will dissolve. All right? But then the rest of it will just sink to the bottom. So you got to be careful on the questions that I give you on these solubility curves, okay? You got to be careful. And what I mean by that is you got to look and see if it falls above the curve, is it completely dissolved or not? If it is, it's super saturated. But if I just tell you I place this much in, but it's not completely dissolved and it falls above the curve, then it's just saturated. We'll give some examples here as we go along. Here we go. All right, what is the solubility of calcium chloride at 5 degrees Celsius? All right, to answer this type of question, you go to 5 degrees Celsius, that's right here. We find calcium chloride, which is this one, at 5 degrees Celsius. That point's about right here. It will dissolve about 60 grams. Now, if you would have said 61 grams, I'm perfectly fine with that. All right, you got to be close. All right, what is the solubility of calcium chloride at 25 degrees Celsius? Let's go to 25 degrees Celsius. Go up to our calcium chloride line. All right, it's about right here. Go over. How much will dissolve? Well, that looks like 90 grams to me. So we'll put in our 90 grams of calcium chloride. All right, what is happening to the solubility and temperature? All right, solubility is increasing as the temperature is increasing. What type of relationship is this? Well, this is a direct relationship, or direct, I can't spell, directly proportional. All right? All right, so it's directly proportional or a direct relationship. If you haven't come across this term in math class, that means as one goes up, the other goes up. Let me look. Let's go back to our curve. You'll see here. All right, as temperature goes up, you'll see the solubility of calcium chloride goes up. As temperature goes up, sodium chloride goes up, and potassium chloride, and potassium chlorate. So you're seeing all these going up. All right? And this happens for solids. Okay, this occurs for solids. When you dissolve a solid into a solution, the more you increase the temperature, the more it will dissolve. All right. Now, there was one example on the graph. Let's go back to it. So first, what's the solubility of cerium sulfate at 10 degrees Celsius? All right, that's this one, cerium sulfate. So 10 degrees Celsius, boom, 10 grams. All right, what's the solubility of cerium sulfate at 50 degrees Celsius? Go to 50, and it's about right there. I'm going to say it's about 3 grams. Okay, if you said 4, 2, whatever. So 3 grams. All right, what happens to the solubility of this? Well, solubility is decreasing as the temperature is increasing. All right, what's this called? These are called indirectly proportional. All right, or an indirect relationship. And this actually happens for gases. Okay, gases are the opposites of solids. When the temperature goes up, the solubility goes down. All right, let's go back and look at cerium sulfate. So you're going to see as this temperature is increasing, the solubility of this is going way down. All right, and this is what happens with gases. So solids, as temperature increases, the solubility increases. For gases, it does the opposites. Alright, at 90 degrees Celsius, 10 grams of potassium chloride is dissolved in 100 grams of water. Is this saturated, unsaturated, or supersaturated? Alright, 90 degrees and 10 grams of potassium chloride. Let's go back to our graph. 90 degrees, here's 90, and here's 10. So I'm going to put a point there at 90 and 10. For potassium chloride, so this purple line is potassium chloride. You see it falls way below the line, and hopefully remember, if not, I'll tell you right now, if it falls below the line, it's unsaturated. How do I know? Because it falls below the line for solubility. How many grams of KClO3 can be dissolved at 50 degrees Celsius? Okay. So I go to 50 degrees Celsius. Trace up to KClO3. And how many grams is that? I'm going to say that's 17 grams. Alright, if you want to create a saturated solution with 40 grams of KCl into 100 grams of water, what temperature would you need to raise the water to? Alright, 40 grams of KCl into 100 grams of water. At what temperature do we want to make a saturated solution? So we're going to go 40 grams. We're going to trace it over until it hits, boom, KCl. It's my orange line here. So what temperature do I need to dissolve this at? Boom, 40 degrees Celsius. 40 degrees Celsius. Alright, if 50 grams of KCl is placed in 100 grams of water at 40 degrees Celsius, what type of solution is created? Alright, I place in 50 grams at 40 degrees Celsius. Now it's above the line, but remember, be careful. I did not say it was all dissolved. I just said we place it in there. And so, alright, so we had 50 grams of KCl and only 40 degrees Celsius. It can only dissolve 40 grams. My question did not say it was completely dissolved, so this is just a saturated solution. Yes, it falls above the line, but it never says it's completely dissolved, and so it's just saturated. Alright, if 50 grams is completely dissolved in 100 grams of water at 40 degrees Celsius. So same question, but this time completely dissolved. Now we're talking about a supersaturated solution. Which substance on the graph is least soluble at 10 degrees Celsius? Alright, let's go to 10 degrees. Which one's least soluble? Well, at 10 degrees, KClO3 is the furthest down. So KClO3 is the least soluble. Whew. Sorry about that. Alright, a saturated solution of potassium chloride is dissolved in 100 grams of water. If a saturated solution is cooled from 90 degrees Celsius to 60, how many grams precipitate is formed? Alright, let's talk about this question. Let's go find 90 degrees Celsius for KClO3. Alright, 90 degrees Celsius for KClO3. It's right here. That looks like 40 grams to me. Alright, so for this point right here, we can dissolve 40 grams. Alright, let's go find 60 degrees Celsius. At 60 degrees Celsius, I don't know, that's about, we'll say 22 grams. Now, this says that it's only a saturated solution. Alright? And so what happens when we cool it out is at 90 degrees it can have 40 grams, but when we cool it down to 60 degrees it can only hold 22. And it's not supersaturated, so it doesn't say dissolve. So this term precipitate means when you do this, is what will happen is our solute will actually start to form on the bottom. Alright? It will start to precipitate out. It starts to come out. It's not going to be dissolved anymore. So if you get a question like this, it's very simple. You take your higher amount of solute and your lower amount and just subtract them. And we figure out that 18 grams will come out and precipitate. Alright. And that is how you do solubility curves. If you need help in class, please call me over. And there we go.